The point of this video is to look at the linear combination of vectors. Read question 8 very carefully, press pause, read it carefully, and when you're ready, press resume. Now, I've got a rough sketch of the situation down here. It probably doesn't bear much resemblance of the coordinates in 3D space, but that doesn't matter. All I'm trying to do is get down the vectors and the points A and B in some way so that I can address the problem. Okay, let's go through the questions. So A, find AB. So I'm finding AB, the vector AB, in terms of lowercase a and lowercase b, those position vectors. So position vectors start at the origin. Okay, so here we go. What am I going to do? Well, I'm going to start by saying OA, vector OA, this one here, plus vector AB, which is what I want to find, is equal to OB, vector OB. So that vector plus that vector will yield vector OB. So simply make AB the subject of my equation. AB equals OB minus OA. And what have we got now? Well, all I've got to do is substitute in the vectors in component form, and away we go. So therefore AB is equal to, what's it equal to? Well, OB is 3i minus 2j minus k, and from that we are going to subtract OA, which is I plus j minus 5k. Okay, so therefore, simple expansion of brackets and collecting like components, we've got AB is going to equal 2i minus 3j plus 4k. Let's go ahead and find vector AM. Well, AM is this vector, this vector here, A to M. And we can see really all it is 4/5 of the vector AB, isn't it? So we just say that. So AM, vector AM is 4/5 of vector AB. And so therefore AM is equal to 4/5 of 2i minus 3j plus 4k, and I need to underline my individual components there, and I can leave my answer like that actually. Let's find the vector OM. Well, OM, I've drawn it in orange there, is simply OA plus 4/5 of AB, which is the same as AM, isn't it? So we just add OA and AM, and hopefully you can follow the working out down here. And finally in this problem, I've got to find the coordinates of M. Find the coordinates of M. Well, all that requires really is for me to extract those coordinates from the position vector there and rewrite them as you see below. Moving on to our next problem, why don't you press pause while you read question 12, and then I would invite you to keep pausing while you work through my solutions. Okay, so OB. Well, OB is going to be the vector, the position vector, and what we do there is we start with B. We always start with the second letter and take away the 0 vector from that, and so we end up with OB being represented as 2i plus 3j plus k. AC, fairly straightforward. Remembering, you start with the second vector and subtract from it the second coordinate, and subtract from it the first coordinate, and so on and so forth. There's nothing particularly extraordinary about Roman 3 and Roman 4. Show that OB and CD are parallel. Okay, well, we can do that by noticing that OB is given as this vector here in component form, and CD as this vector here. We note that we can factorise CD, and we notice that what happens then is that CD turns out to be twice the size of OB. So they're the same vectors, it's just that CD is twice as long as OB. So if they're the same vectors, they are parallel as well. In question 22 here, I think you'll find part A quite routine. Press pause and work through the examples. Perhaps the only tricky part is Roman 3, where hopefully you can see what I've done. Multiplied each position vector by a scalar, and collected the components in the usual way. Okay, now I'll get on to part B on a different screen. So with part B, we are going to solve that by forming simultaneous equations, just as we did when testing for to see whether vectors were linearly dependent or independent of each other. So I think you'll be able to follow the working, and what you're going to find, so press pause maybe, what you're going to find is that you do appear to get solutions where k is equal to -3 and -3 and L is equal to 2, K is equal to 3 and L is equal to 2. But it so turns out that when you substitute that so-called solution into your third equation, it does not check out. So that means that there is no solution there is no combination of K and L that would enable us to satisfy this condition that Ka plus Lb equals this third vector C. So a bit of a trick question there. And that ends this video. Thank you for listening.